Okay. Well, most of you, I think, did pretty good on the first one, 48. You just had to simplify it. And to simplify it, you just got to find a number that all of them can be reduced down by dividing with that number. So on this first one, you would divide everything by 3 to get the smallest ratio. So it's C2H2O. For B, that's glucose, and so the simplest ratio or empirical formula for glucose, everything is divisible by 6, so it's CH2O. And then the last one that you had to do was 8, 6, and 4. Everything's divisible by 2 to get the smaller ratio, so it's C4H3O2. Questions on that? Okay. So, we'll go through this pretty quick because I looked at yours to see kind of how they're doing. The next one that you had to do was just, you were given all the information. And so, this is the actual formula. And then you realize 194 was the molecular formula. Then you add your 4 carbons, 5 hydrogens, 2 nitrogens, 1 oxygen. That gives you 97 for the mass of that whole thing. So then you divide 97 and 194 goes in twice. So everything doubles. 8, 10, 4, 2. This one, just having some students kind of getting to a point where they get to 1.2 and 1.8 and then they kind of maybe round up or round down. Can't do that. It's got to be really, really close to round. So divide everything by 1 and 1.2, and then we get these. We've got to multiply everything by 2 to get the ratio. A lot of times you don't even have to do this. A lot of times you go 1.5 is like 2 to 3. So in your head you can do that and not have to worry about doing this step. Okay? Now, some of you did not take this a step further. You assume that that was your molecular formula. You can't do that. Okay? So the molecular formula mass was, on that one, what was it, 100? Okay, 165. So you had to compare this weight to this weight they give you for the molecular formula. Well, when you add this all up, it's 165. So it's 1, which means that is your molecular formula. That is your molecular formula. So some of you are not looking at that, and that's going to get you in trouble, especially on this next one. Some of you left it as CHN. Okay, some of you just left it at that and said, that's my answer. Well, that's the empirical formula. It says that the molecular formula mass, or the molar mass for the compound is 135. So you have to add it all up. You get 27, and then it gives you a whole number that you can multiply all your subscripts by. So C5H5N5. And that is that protein that is part of RNA and DNA. Adenine. Okay? That's what it would be. Questions you guys have? Okay, what I'm going to show you today is really pretty simple. You just have to have the right numbers that you're dividing to get your mole. Students that have been doing these wrong, they're writing the wrong number of grams down for water. And so I just got to make sure that you guys are thinking the right way when you have to do your setups for it. Now, so the next slide tells you a little bit about what's called compounds are hydrated. So if they're hydrated, what do you know about them? They got water in them. And the mole ratio will always be a whole number ratio of water molecules, because you either have one whole molecule or not a molecule. So these are all mole ratios that we're dealing with. So just take a couple minutes to write this down, and then I'll show you a problem. And then I'll give you a couple to do. You should be done with it by the bell rings, because we're going to get to it a little bit sooner than we did the other couple classes. So go ahead and write that. As you're writing that, we got a lab tomorrow. And the lab tomorrow is really similar to the lab you just did, where you're going to take a solid, you're going to put it in a crucible that's been pre-weighed empty, that has a mass. You're going to put about 5 grams of a solid into it. And then you're going to heat that solid, but you're not going to heat it red hot. You're going to heat it probably with the tip of the outer flame and not the tip of the inner flame. If you heat it with the tip of the inner flame, you will have a chemical reaction that will decompose it, and we don't want that. So we'll heat gradually at first, and then we'll heat it up a little bit warmer. We won't have to do it for 10 minutes. We might have to do it like for 5 or 6 minutes. But we have to let it cool, weigh it, and then we'll have to do it again just to make sure our final weight is correct that we're going to do. So we'll do that tomorrow. Probably have it due like on Wednesday. We will have a test on Tuesday. I'm giving you the review out today. The review has all the answers on it. So as you do your problems and your calculations, you can check your work as you go. And then come Monday, if you're getting something wrong, or if I have a wrong answer because I did it wrong, then we can go over that, correct that if that's the case. So a compound that's hydrated has water molecules part of the crystal. And it's always going to be a whole number of molecules that are going to be attached to the crystal. So if we're going to determine the correct formula, we need 2 things. We need the mass of the water and the mass of the leftover solid after driving off the water. So those are the 2 weights we need to use. There's going to be 3 weights you can use. You got to make sure you're grabbing the right 2 weights when you're doing the calculation, because students are taking the wrong weights to do the calculations, and you got to make sure. If you pick the wrong weights, they're not going to give you the whole number ratio. They're going to be way off. And it should be a really nice whole number, or really super close to a whole number when you do it. So I'm going to give you 2 weights, describe what those weights are. We're going to do sample calculation to show you so you can have it in your notes, and then you'll have a couple that you'll have to do. Okay? So if you go ahead and write that down, we'll talk about what these numbers represent. So this is cobalt chloride. Yes?
Is that XH or is that times H?
X, be a number that will be substituted into that later on. Okay? Because I can't tell you what the number is here, we're going to have to calculate it. So this is cobalt chloride right here. And this is what a person would do. They weighed out 1.62 grams of it, they heated it up, they let it cool, and they reweighed it. And they ended up with 0.88 grams of the residue. The residue is without the water. Okay, it doesn't have water in it. So what we need to do is we need to find the ratio of moles between cobalt chloride. So we got to find the moles of CoCl2 and compare it to the moles of H2O. That's what we've got to compare them to. So we've got to make sure we have the weights out here front correct so we can do that mole comparison. So, do we know the mass of cobalt chloride?
No.
Mm-hmm.
Yes.
Yeah, 828.
Yeah, because we heat it and we drive off all the water, and what's left behind is just the cobalt chloride. So it's the 0.88. And that's the CoCl2. Okay, we're going to go ahead and set that up here later. We're going to get our moles. Okay, do we know the mass of water? No, we don't. But how would we determine it? Yeah. So this has the COCl2 in it. This is with in water, and this is without water. So if I subtract those two, then it gets rid of my COCl2. And I'm left with just H2O. So this would give me grams of H2O, and that would be what? 0.74. Okay? So then that 0.74 grams of H2O will go here, and then we'll have to do our conversion for that. So we would have to look up cobalt, and we got one of those, and that's 58.933, and we have to add it to 2 chlorines. So we go 58.933 plus 2 chlorines, and we get, make sure I got that right, 129.83. Okay, so when I do the calculation, I'll get moles out of that. Then I'll do the same for water. Water is 18.02 grams to 1 mole. And I'll get the moles of that. So now I can look at my mole ratio when I do that. I'll take the 0.88 divided by the 129.83. I get 0.006778. Moles. And then I'll do the same for water. Now water is always going to be bigger. If it's not bigger, you did something wrong. So it's going to be 0.041065. Maybe the farther you take it out, the closer you're probably going to get to a whole number ratio. So these here, you probably want to take out a little bit farther. If you take and make it 0.007 and then 0.04, it's not going to be close enough. So you got to make sure you take it out farther. So then the last step, what you do is you look, how does the moles of H2O compare to the moles of the residue, or this case CaCl2. So now you put down here the 0.006778, and up here you put the 0.041065. And you should get a whole number out, or really close to a whole number out when you do that. And you get 6.06. So up here I have 6.06 moles of H2O for every 1 COCl2. So then what is X? 6. X is 6. What is COCl2? 1. Okay? So then if I rewrote this out, I would write it as COCl2 dot, and then since I've got 6 waters, that's how many is going to be in there. And when I look at my answer on here, it says 6H2O on here. So that would be, that matches up the way it's supposed to be. So, okay, and then, so these are all actual examples, actual hydrates that you're doing. Any questions on that? Make sense? All we're doing is finding moles of both, comparing the moles, and then water's always going to be a whole number. Yep.
What's that little number you wrote down here?
18.
No, on 6. All right. 6.
Far right. 1 to 6.06. Yeah. Okay. I'm going to go ahead and give you 2 to work out. Shoot, you got a lot of time to get this done, then I'm going to give you out a review too. And you guys, whenever you guys work on that, we're just going to go through it on Monday, so it's on your own time on that part. So these would be the two that you would do, put in your notes. And these X's will always be whole numbers. Really, really super close to whole numbers.
That's funny.
When you do. So when you guys do the lab, you should get a whole number ratio. You may, since it's an experiment, not have perfect data. So like if you come up with a number that would be, just for example, 3.2, what would you do with that since it's an experiment? What would you make it? So you make it free. You say, hey, I got 3 waters. You got to be logical when you give your answers. Okay, they got to have a little logic to them. You go, okay, I'm not going to go ahead and multiply that out. So you'll know about that when we do the lab and that. So Fridays are good for labs. We get the lab on Friday. Go through that.